The idea of the meeting is to give short introduction of Kadcast and to give an idea of what benchmark results we've got compared to the Gossip protocol implementation. So as Carlos is already here, Carlos actually was the first developer of Kadcast implementation. So first, what is Kadcast? Kadcast is a peer-to-peer protocol that is designed to be a much more efficient approach of data propagation in P2P network. So when I say more efficient, the point is to achieve faster wire message propagation, to reduce the amount of in short, Kadcast is alternative of our P2P layer. In other words, currently we have Gossip protocol for propagating messages between all network nodes. The Gossip is pretty standard for any P2P network. Kadcast is a much more innovative approach, which is trying to be much more efficient. By efficient, more efficient, the point is that it should allow us to propagate messages on the wire between nodes within one network in a much faster way and with less bandwidth, and also in the same time improving the network soundness. Saying that, Kadcast compared to Gossip, there are two major differences I would highlight between Kadcast and Gossip. The first one, and maybe the most important, is that Kadcast is structured network protocol. It is based on Kademlia routing state, which means that each node, based on its ID, has a particular position in a binary tree. It is capable of propagating messages to other leaves in that binary tree. The other difference compared to Gossip is that Kadcast should be fully based on UDP transport. Just as a reference, our current implementation of Gossip relies on persistent TCP connections, which is also a huge difference. And to make this possible, Kadcast recommendation is to use a RaptorQ encoding protocol to make messaging on the UDP much more reliable. There are three types, I would say, of problematic situation when you use TCP or any networking stuff. The one is latency. The second one is packet loss. We've got also packet reordering, but all this is around the quality of the network connection between pairs. Another property of the networks, of course, is the number of the nodes that the network consists of. The more nodes we have, of course, the more time one message will need to reach all of them. So I'd like to show very quickly what are the results of a RaptorQ encoding compared to simple TCP send. So just to highlight once again, RaptorQ is a data encoding algorithm or protocol, we can say, that is helping us to transmit data on the unreliable transport, like it is UDP, in a reliable way without using any packages. And so I have one test here. Okay, so I was saying that if we have bigger network latency, then we can see that RaptorQ plus UDP is much faster. It needs only 300 milliseconds to deliver this data compared to TCP send, which is almost 3 seconds to deliver this same size packet. We have integrated this RaptorQ within part of our Kadcast implementation. And back to Kadcast. So how do we test actually our Kadcast and how we compare its performance to the initial Gossip implementation? I've got on my local machine a test harness which runs 200 nodes. Of course, to each node is running together with one blind bit instance, and this network is also running with a local Dusk seeder. So I've got this harness on my machine. Just let me change a very important setting. So when I run this locally, it's very important in order to get real results, to have to emulate network latency. So this is some kind of a feature that Linux provides. If I now ping my local host, you can see that the latency is 4 milliseconds. So thanks to this emulation, we can run more realistic local tests. And I've got a network monitor, which I call here collector, which will listen for this data I need to measure. So if I run this network with only Gossip enabled, 200 nodes with 4 milliseconds latency, the average Gossip nodes per second here is almost 300, and now running a few messages with Kadcast, its average one is a bit more than 500. It reaches almost 600 in one of the messages on the wire. So this is what I wanted to show you guys. The high latency we've got in the network, in the blockchain network, the better Kadcast perform, and the more nodes we've got in the network, the same rule apply. Kadcast is more efficient. And my expectation is that when we have much bigger networks, I mean, in terms of thousands of nodes, this difference will increase significantly in Kadcast advantage. And yeah, I think that was the point of this demo. If you have some questions, let me know